Hey guys, welcome again to the Maths Club. If you're just joining us, you're welcome. For some time now, we've been on a series on number bases, looking at introduction to number bases, converting from number bases, and now we are in addition in number bases. So we've looked at some other things apart from this adding in bases greater than 10. We looked at adding in bases less than 10. Right, so you might want to check the pop-up that will appear to lead you to all of the things that we've been doing on number bases. So today, right, so we're going to be talking about adding the bases greater than 10, and as always, we're going to use examples to actually bring it home. Now, let's start with something very simple, something very basic. So we have 759 in base 12 plus 925 in base 12, right? Let's solve that. So I'll switch over to the Excalibur. Then we have 759 in base 12 plus 925 plus 925 in base 12. So this is 9, right? So in continuation of the way we've been doing it, so we said we're going to add like our normal addition, right? 9 plus 5, that will give you 14, right? And as we said before, we will divide that 14 by the base we're operating in. What base are we operating in? Great, we're operating in base 12. So if I divide this by 12, what am I going to have? How many times can 12 go in 14? That will be 1 with a remainder of 2, right? So what will I put here? Will it be the whole number or will it be the remainder? Great, it will be the remainder, so that will be 2. Then I'll carry over the result, which is 1. So 5 plus 2 is 7. 7 plus 1 is 8. If I say, and like I said before, I said for numbers less than the base, you don't need to bother yourself doing all this division. It's always going to be this sum that you get. So in this case, I will just put 8, right? Because not any of that. Then the last one is 7 plus 9. That's 16, right? So if I say 16 divided by 12, because I'm doing this because it is greater than or equal to the base. So if any of these things are actually strange, right, you might just check the video that would pop up right now at the top. So 12 divided by 16 is 1, right, with a remainder of what? Of 4, right? Because after you divide 16 by 12, you're going to have, you can only go once and there'll be a remainder of 4. So I'll drop the remainder 4, and like I said, you carry over the 1, that there's an imaginary 0 here that you're going to add. So you bring that. By the time you add the 1 with the imaginary zeros, right, it will bring 1. So if I do this in page 12, so the summation of these two values is actually 1482 in base 12. Let's see our answer. Let's see if we're correct. 1482 in base 12. Yes, we are. So we can mark ourselves. Very simple, right? So imagine if I was converting this to base 10. That means I'll be doing 12 squared. 12, it will have been so complicated, right? Like I said, whenever you have the same base, always try to use this method. Great, so we're doing well. Now let's look at this question. It says we have 13 in base 15 plus 9 in base 13. I want to leave the answer in base 2, right? You know, I said something. When we have different bases, what are we going to do? Great. We are going to do what? We are going to convert them to base 10. Right, so convert this one to base 10, convert this one to base 10, then add in base 10, right? Then I'll now convert it to whatever base they want my answer to be in. So if this is strange, you can also check the video that will pop up at the top right corner. So like this now, so let's do it. So we have 13 base 15. 13 base 15 plus 9 base 13. And we have to leave in base 2. So it's very important because we might get carried away. So I'll just circle this. Right. So like we said, the first step is to convert to base 10, Abby. So convert to base 10. So if I convert 13 in base 15 to base 10, how are we going to do it? Like we've been doing, we'll just say 1 times the base, which is 15, plus 3 times the base, which is 15. And then from right to left to give you powers, yeah? So 0 and 1, great. So if I do this, this would be 1 times 15 raised to power 1 is 15, plus anything raised to power 0, like what we'll be saying, is equal to what? 1, great. So 1 times 15 is 15, plus 3 times 1 is 3, so this will give us 18. So this is 18 in base 10. Great. Now we'll convert the second value, which is what? 9 base 13 to base 10. Like I said, you always want to convert, you always want to compare oranges with oranges and apples with apples, right? Ideally, right, any number that is less than 10. So let's see now. So I'm having 13, right? So any number that is less than 10 really will be that number in base 10. But don't take my word for it. Let's convert this. So this will be 9 times 13, right? This is the only thing. So this one will have a power of 0. So that will be 9 times 13 raised to the power 0. 10 raised to the power 0 is 1, right? So the value is what? 9, right? So in base 10. So you can see we had the same value in base 13 was the same value in base 10. So any number less than 10, regardless of the base, right, would be the same value, right? We'll just take that. So now, what are we going to do? We're going to add 2 of them, and then we'll convert our value to base 10. So let's add. So adding, right? That would be 18 plus 9. What is 18 plus 9 in base 10? So 18 plus 9, they are both in base 10. Base 10. This is our normal counting values, right? That will give us 27 in base 10. But let's actually leave the value in base 10. No, they said we should leave it to what? In base 2. So let's convert it to base 2. You might want to pause the video and really rejig your memory on this. Welcome back. So converting to base 2. To base 2. So a long division method, right? 27, right? 2 in 27, 2 in 2 is 1, 2 in 7 is 3, but there will be a remainder of 1, right? 2 in 13 is 6, right? Because 2 times 6 is 12, so there will be a remainder of 1. 2 in 6 is 3, there will be a remainder of what? 0. 2 in 3 is 1, right? But there will be a remainder of 1. We said we'll keep on dividing till we get 0, right? So 2 in 2, that will be 0. Then I'll bring down this 1 down. So by the time I look at the value, right, at the end of the day, the sum of the value, right, is from the bottom 11011, 11011 in base 2. Let's see if our answer is actually correct. Great. So you see we're doing very great. We're doing very great. So let's mark ourselves very good, right? So whenever we're given the same base, do your normal addition. Whenever we're given in a different base, right, convert this to base 10, convert this to base 10 and add them together. Let's take it a notch higher. A notch higher. Are you ready? Fasten your seatbelts. Now this, right? If you remember, when I was doing introduction to base, right, and that video would actually pop up now. So if you do not, if you want to review it, right, you can just click on the link at the top, right, at the pop up at the top, and take us to that video. We mentioned things like that. When you're actually our fundamentals in numbers is number 0 to 9, and if there is a need for more values, right, we go to the alphabetical order, right? So let's see. So I did a small sheet here, so you can see non-decimals greater than 10. So we said if we had numbers from 0 to 9, we still have 0, 0, 1, 2, 3, 4, 5, 7, 8, 9. If I was working in base, let's say base 11, right, I would need numbers up to 10. But in my normal decimal distance, the counting numbers that we had were from 0 to 9, right? So that's where we now introduce all this alphabetical order. So if I needed an extra number, if I was in base, if I was operating in base 11, I needed an extra number. That extra number would be A. So I'm just recapping what I actually did in that particular video. So you might want to watch it if some of these things are not really clear, right? So if I was working in base 12, my base numbers would be from 0 to B. If I was working in base 13, my base numbers would be from 0 to C, right? If I was working in base 15, my building block would be from 0 to E, right? Just like we said in that video. So let's continue. So in this particular thing, it says that I want to do 1A, 1E in base 16 plus 16 in base 16, right? So let's do. Remember, they're in the same base, so I'm not going to convert to base. I'm not going to convert to base 10. I'm going to solve it like this, right? So let's see. We said 1a 1e in base 16 plus 16 in base 16, right? You know, we said something in that last time that, so all I just really need to know is what is e. E would always be e. What is e? If I do a comparison of that e to the e that I have here, so look at this is the non-decimal representation and this is the decimal representation. That means that if I have e in any base greater than 10, right? If I have only e in any base greater than 10, that means that if I want to convert it to decimal, that means that e will be number what? Number 14. If I have a, that a will be number 10. If I have g, that g will be representing number 16 in base 10. Do you get? Now we have e. E is representing one number. E is representing 14, right? So if I come to this place now, that means that this e is 14. So what we have here basically, even though I'm saying e, what I have here is 14 plus 6, right? So 14 plus 6 is what? That is 20, right? 20. But we're working in what base? Base 16. Great. So like always, I'll just say 20 divided by 16, right? How many times can 16 go in 20? 1 with the remainder of what? The remainder of 4. So I'll drop the remainder, which is 4, right? So this base 16 and carry over the 1, right? 1 plus 1 is 2. 2 plus 1 is 3, right? 3 is far less than 16, so I'll drop it down, right? I'll bring down my a, and I'll bring up my 1, right? So you can see, I was able to solve this easily, right? Because I know that whenever I'm reaching bases that are greater than 10, I have to reference, so this could continue to h, I, j, k. I just stopped at g to make it. I just need to have a reference table, right? I need to know basically that a is 10, right? B is 11, C is 12, D is 13, so E is 14. So if I want to now add, so even though I'm seeing E here, I'll convert that E to the decimal representation, which is in this case is 14. Then I'll add it to the number in this case, which is what? 6. 14 plus 6 gave me 20. That is just the part that is just different. Every other thing is as we have been doing it. So I'll divide that 20 by the base I'm operating in, which is 1 remainder 4. I'll drop down by 4 and carry over the results, which is 1. Add, continue my addition. And this is the value that we have. Let's see if we actually got it right. 1A34 in base 16. We did very well. Let's solve one other example. I know that this part might be a bit shaky, right? And that is very fine, right? By the time you solve the other example, right, everything will really add up. I will still encourage you, if you have not watched the first video that we did, Introduction to Base, please do. We actually broke down all these 1A, 1E, all of these things there. Great. So adding in bases greater. Let's look at this other question. So we're told to add AB13 plus 1A in base 11 and leave our answers in base 10. In this case here, we would have to convert our, I told you that when you have different bases, it's best that you convert each of them to a singular base, right? In that case, that is base 10. So let's see. AB in base 13 plus 1A in base 11. Great. How are we going to, so we know step 1, convert each of them to base 10, right? So to base 10, right? That will be A times 13 plus B times 13, right? Plus 1 times 11 plus A times 11. This time I'm doing everything at once, at a go. Normally I'll break this one, I'll do it, I'll break this one, I'll do that, but no, not really, right? So if I'm concentrating on this first 2 is coming from this place here, so I'll start from here. I'll give it the power of 0 and the power of 1, right? This 1A11 is what I did here, right? So I'll give this one the power of 0 and the power of 1, right? Like I said, normally I'll have broken it down, I'll have resolved this part, done it, then resolve this part, done it. I'm just doing 2 of them together just to save time, right? So what do we have here? We have A times 13, right, plus B times 13 raised to the power 0 is 1, right, plus 1 times 11 raised to the power 1 is 11, plus A times anything raised to the power 0 is what? Is 1. Great. Now, how are we going to convert these A and B's? We just need to go to our table, right? Our table. We know that A is in decimal is what? Is 10, right? So I'll just come here and just say what? 10 times 13 plus, of course, if A is 10, then that means B is 11. 11 times 1 plus 1 times 11 plus A is 1. A is 10, sorry, plus 10 times 1, right? So I'll just simplify. This is 130 plus 11 plus 11 plus 10, right? So 130 plus 11, right? That is what? So if I add 11 to 130, that is 141. 141 plus 11, that is what? That is 152. 152 plus 10, that is what? 162. And you agree with me that we converted this one to base 10, we converted this one to base 10, then we added. So that means our answer is already in what? In base 10. So by time, let's see if what we even did is correct. Let's first check if what we did is correct. So our answer is 162. Great. That means that we actually got it correctly. So what are the takeaways from this? First, you need to understand what all these A and B's in numbers that are greater than 10, what they represent. And then if you are having solutions, right, in the same base as always, just add them normally like we always do, right? Add them normally like we always do. In this case here, yeah, so this was base 16, right? Knowing what E represents was actually the breaking point in this particular question, right? Every other thing is still the same thing, but if you have them in different bases, right, just convert them to base 10. So I converted this one to base 10, I converted this one to base 10, then I added. Since our answer said we should leave it in base 10, we were good, but if our answer told us that we should leave it in any other base, right, we'll have done our long division method, right, and then still arrived at our answer. Do you get? So let me just put a small tweak to it. So instead of saying in base 10, let's say we wanted to end it in base, let's say in base what base should we use? Base 13. So let's say base 13, right? So that means that I have to convert this 162 to base 13. So let's do that. 162 13, right? So let's go to, let me use my calculator. So I can say 162 divided by 13, right? That gave me 12 as a whole number. So that would be 12, right? But what would be the remainder? So I'll just say 12 times 13, right? So I have 156. But here I had 162. That means that there's a remainder of what? Of 6, right? So if I come here, if I divide this one by 13 too again, this will be what? 12, that will be 0. Remainder what? Remainder 12, right? But because I'm working in base 13, this 12 here, 12 in decimal, this is decimal 12, right? So I need to look for what the what 12 is in base 13, and that's very simple. So I can come to my, if I come to my table here, so 12 here is C, right? 12 here is C, right? So I can just come and just say, so this would be remainder C. So from bottom to top, in base 13, my answer is C6 base 13, right? Now let's see what we actually did was correct. So this is 162. Let's convert 162. I have this online converter that I use, right? So we have 162, right? This is from base 10 to base 13. So if I convert this, can you see that? C6. Can you see? You can see that our answer was actually correct. So it's still basically the same thing. So whatever you have here, you just do, you convert that value 12 to your, you use that your table, right? So 12 in decimal is actually C, right? All you need is just a very small table like this to be able to solve this particular question. All right, guys. So with this, we've actually come to the end of this particular addition. If you found this video very useful, don't forget to like, don't forget to subscribe to our channel to keep being updated with all of our contents. And if you have any question or anything that you need clarification on, don't forget to comment, right? I'll be there to answer all comments. Thank you very much.